Okay, so now we have the universal 360 degree value chart in front of us. Let's look deeply into what this chart indicates. Okay, it's specifically a universal 360 degree chart. And this chart expresses each sign, noting that there are 29 degrees in each sign. Okay, now 30 degrees times 12 is 360. But within this chart, each degree is reduced within each sign. So let's zoom in on Aries, for example. Now Aries starts at the beginning from 0, and its value equals 0. It goes to 1, and then its value equals 1. Alright, and so forth and so on, until you get to the value of 29. And so its value is 29, starting from 0. But if we continue, we go to the sign Taurus. Now, Taurus's value starts at 0 because it's the beginning of the next sign. So 30 is actually the 0 degrees of Taurus. And so when Taurus starts, it starts at 0 because of the progression to move towards 360 degrees. So on this chart, Taurus describes 0 to be equal the value of Taurus's 30 degrees. So now when we go to 1 degree, it equals 31. We go to 2 degrees, it equals 32, etc. until you get to the 29th degree. And so the 29th degree of Taurus sign, or the degree, is 59. Okay, so now we go back up and we go to the next sign, which is Gemini. Okay, and Gemini starts at 0 because it is a universal 360 degree value chart, and this value chart expresses each degree as the value matches the 29 degrees of that sign. So you have 0 degrees of Gemini equaling 60 degrees. 1 degree of Gemini equals 61. So if the sun was shining in 0 degrees as it transits into that sign, it will equal 60 degrees. Once it goes, because the sun goes 1 degree per day, the next day it will be 1 degrees as it goes into Gemini. 1 degrees will equal the universal value of 61, and so forth. 2 is 62, 3 is 63, because now we're in Gemini, and that starts from 60, right? And so when we go to the 29th degree of Gemini, it will equal 89 degrees. Go to Cancerian, the next sign, which is 0 degrees Cancerian is summer. But when the sun enters 0 degrees of Cancerian at summertime, it will equal 90 degrees. And when it goes to its next degree, which is 1 degree per day for the sun, it will be 91, etc. 2 is 92. So this value, 360 degree value chart, indicates the value of 1 degree, or the degrees that a planet will travel through as it's going through its cycle. And each sign equals 30 degrees, or 1 month. So when we get to the end of the 29th day of that month in Cancerian, 29 will equal 119. Okay, let's move on to the next sign is Leo. Okay, so now we get to Leo. The 0 degrees of Leo is equal to, on the universal 360 degree value chart, is 120 degrees. The sun is the ruler of Leo, and as it passes through 1 degree per day, it will enter the first degree of Leo, and that will equal 121 degrees. The second day, it will equal 122. So this is the value placed on the degree that the sun is in at that particular degree day. Okay, as it passes through that sun sign, Leo. So we go to the 29th degree, and that 29th degree equals 149. We continue to go to Virgo, and Virgo's now the sun enters the autumn season, it will enter 0 degrees of Virgo, and that 0 degrees is actually the 30th degree of the previous sign, Leo. So that 30 becomes the 0 degrees of Virgo, and that value is 150 degrees. Okay, the next day it'll be 1 degrees because the sun moves 1 degree per day, and that value will be 151, etc. 2 is 152, and as we progress to the 29th degree, as you know, there's only 29 degrees to a sign, or 30 degrees to a sign, because that indicates the month that the sun is transiting through that sign, that month, that season. So 29 equals 179 on the value, the 360 degree value chart. Okay, and that degree has a value of 179 at the 29th degree of Virgo. We will continue with the next sign as the sun travels through its month throughout the year, and we enter Libra. And Libra, we know it's still the fall season, right? And so we know that when the sun enters Libra at 0 degrees, we know we're in autumn, or we know we're in fall or autumn. Traditionally, it's 180 degrees away from springtime, which is Aries. Okay, so the 0 degrees, when the sun enters 0 degrees of Libra, the value of that indication would be 180 degrees away from springtime, which is the opposite sign or the opposite season of spring, of Aries, spring. It's the equinox. Okay, so the equinox of Aries is now we enter the equinox of Libra, and that will indicate our fall season in most northern regions, northeastern regions, the northern part of the United States. Okay, 0 degrees is equal to 180 universally. As the sun passes through the sign Libra at 0 degrees, it will be 180 degrees. 1 degree, as the sun transits through 1 degree per day, as it moves throughout the seasons, it will be 1 degree of Libra equals 181. 2 degrees equals 182. So we place a value on each of the degrees as the sun is passing through that season. So we go to that whole month, and there's 30 degrees to a sign, there's 30 days to a month, and we get to the 29th degree of Libra, and that will indicate 209. degrees. So you see the value placed on a degree that the sun is going through. Now it's a computation. You can now computate a degree difference between any other degree, which makes this easy to computate the distance from one sign to another. So now we go through the season of Scorpio. Okay, and Scorpio, as we know, is still in the fall season or autumn season. And so we get to 0 degrees when the sun enters Scorpio. We enter 0 degrees, okay, because the sun is going through the season of Scorpio now. So all Scorpions are being born. Now each day a Scorpion person is being born, the difference is in the day. That particular degree for that particular day will add up to, if that person was born in the first day of Scorpio, that value placed on that degree of the sun passing through that sign is 211. The next day that person is born under the Scorpio season, let's say he or she is born on 2 degrees of Scorpio, then the value of that degree difference would be 212. 1 degree difference from the previous day, which is 211. The next day the sun enters the 3rd degree of Scorpio, that value is 213. Now it reaches the end of the month at the 29th degree, which is the end of the Scorpio season. Then the value of 29 equals 239 on the universal 360 degree chart. Okay, so you can see the computation of the value that's placed on the sun going through that degree on that particular day. And so now we'll proceed to the next sign, which is Sagittarius. And so Sagittarius, when the season enters Sagittarius, we're still in fall, but at the end of the fall season. And so we enter 0 degrees, and all Sagittarians are being born at this time when the sun is passing through these degrees or this season. And so when it enters, say, 0 degrees of Sagittarius, the value of 0 degrees as the sun passes through that degree is the equivalent value is equal to 240 degrees on the 360 degree universal chart, because everything is in a vacuum of 360 degrees. So each time the sun passes through its season, the 1 degree that it passes through for that seasonal condition has a value on it. And so Sagittarius' value on 0 is 240 degrees. The next day the sun goes through the 1st degree of Sagittarius, it equals 241, and so forth. The 2nd day, because the sun enters 1 degree per day for a whole year. The sun transits 1 year. This is why you have a birthday, and each person is born, has a birthday, and is born at one of these degrees. So whatever day you were born will indicate the value of the degree of that sun sign, which individualizes the person. And so let's see. On the 3rd day the sun enters Sagittarius, its value on the 360 degree chart is 243. Now remember, we're in aspects, and so this is so important. This is the key into understanding how aspects are linking to one another. Aspects are joining one planet to another. Aspects are joining one planet to another by way of its aspect. And so the aspect is the degree. The aspect is the degree difference between one or more planets, or one planet to another planet. And so to differentiate between the degree difference, you need to know what that value is so that you can computate the difference between that aspect between one planet and another. Okay, so as we proceed, we'll go to, say, Sagittarius at 5 degrees. Now, the value of 5 degrees is equal to 245 degrees on the universal value chart. So as we proceed, we'll go to the 29th degree of Sagittarius at the end of the month for that season. Because the sun only transits through a season, or a sign which represents that part of the season that the sun is transiting through for 29 or 30 days. And that equals a month to us, Earthlings. And so the 29th degree, as the sun phases through 1 degree at a time, will equal 269 degrees on the universal 360 degree vacuum that it interacts within. Okay, 360 degrees is a universal total circle that we are aware of. So each degree within that circle has a value to it based on how the sun or any of the other planets are passing through its cycle throughout the degrees. Okay, so now we go on to the next sign, which is the season. We're coming out of the total season of autumn, or fall as we call it, or some call it, and now we enter the season of winter. Now we know 0 degrees Capricorn indicates the season, the Capricorn solstice of the season of winter. 0 degrees indicates the beginning of winter, and Capricorns that are born in the winter season. Okay, and so if you're a Capricorn, you weren't born in the winter season, then you're an alien. But anyway, Capricorn 0 degrees on the universal chart equals 270 degrees. All right, the next degree that the sun enters at 1 degree of Capricorn has equivalent value on the 360 degree chart as equaling 271. And this means that the sun is going through the season of Capricorn. So each person, each day, is born at a particular degree for that particular day, which individualizes that person and gives that person a value unto themselves, which gives them an individuality. All right, we'll go to the 29th degree at the end of the month of Capricorn, and that will indicate the 29th degree for that month, because remember, there's only 29 degrees, in some cases less or more, for a month. All right, and so basically you have 29 days to a month. All right, 30 times 12 is 360 degrees. All right, so the 29th degree of Capricorn, it has an equivalent value on the chart of 360 degrees of 299 degrees. As we progress to the 360 degree totality, or as I call it, a vacuum within the 360 degree circumference of a circle. So let's progress to the next sign after Capricorn, which we know as Aquarius. And we're still in the winter months, but if you think winter starts in Capricorn, well, it does, then that would be the refrigerator in terms of cold. But when we get to Aquarius, now we're in the freezer department, because it should be even colder. And so Aquarians start during this winter season, because they're winter babies as well, and the Aquarian that's born at 0 degrees of that, when the sun enters 0 degrees, is 300. Okay, Okay, if they're born at 1 degrees of the Aquarian sun, as it transits through 1 degree for that month, then the value equals 301. And the 3rd degree of the sun transiting through 3 degrees for that month equals 303. 303. All right, so as we progress to the 29th degree of that sign, okay, the end of the Aquarian season is only 30 days to a month. Then the 29th degree is the final day of that month. Okay, because 30 is the beginning, the 0 degrees of the next month. So we ended at 29, and 29 is 329 for the Aquarian season. And the last month of the year starts with Pisces. And Pisces, people that are born under Pisces, they are born in the season between winter, the last part of winter, and the beginning of spring. So we call this winter spring. And so the 0 degrees of Pisces is 0, the degree as the sun passes through 1 degree per day. The 0 degrees of the Piscean month would be equal to 330 degrees. Now you see we're on our way to 360. But each value as the sun passes through 1 degree per day has a value to it that equals in a mathematical calculation that can be computed between other signs and other degrees. So this computation of degree is so important when you're doing aspects. Okay, so the second, let's say a person is born on the 2nd day of the Piscean, when the sun is passing through the Piscean season, then the 2nd day would be 2 degrees. That 2 degree value on the universal 360 degree value chart would be equal to 332 degrees. And so as we progress to the next season, or next degree, the next degree will go all the way to 29 degrees of the Piscean season. And so the 29th degree is the end of the month for that season. And so that value is 29, or the degree for that month is 29 as the sun transits through its 29th degree, and that value is 359. So now we only know there's 360 degrees to a circle. So that last day of the Piscean sun, as it enters its 29th degree, the value is 359, which completes the cycle that the sun is transiting through, because it's only 360 degrees that the sun transits through, to giving everyone a birthday. And so now we go back up to Aries, and you'll find that 0 degrees is the 30th degree, the 360 degree that starts Aries all over again. And that's the explanation of the 360 degree chart that is so necessary to understand when you're doing aspects. This key will give you the computation, mathematics, and calculations that will actually calculate the difference between the energies that are operating throughout whatever degree that sun is passing through as it's transiting through its cycle for 1 year, or any of the planets, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, and the moon also. Okay, all of the planets are calculated like this because all of the planets transit through a cycle that when they enter a season or a sign, those values that it passes through, when it passes through a particular degree, adds up to a computation. And that computation can be calculated for the difference between each sign.
Now let's go into a little bit about the ether of space-time itself and what it's created of. Sylvester James Gates, Jr., he's an American theoretical physicist who works on supersymmetry, supergravity, and superstring theory. He retired from the physics department at the University of Maryland College of Computer, Mathematical and Natural Sciences in 2017, and he's now the Ford Foundation Professor of Physics at Brown University. He was the University of Maryland Regents Professor and served on former President Barack Obama's Council of Advisors on Science and Technology. Yeah. But I like to provide these valid sources to you so that you can see it's not just me up here, some conspiracy guy who's been surfing Google and YouTube. I want you to understand that what I'm presenting to you is coming from very validated individuals. Let's hear what he has to say about the ether of space-time and what he discovered.
It's New York City. It's March 7th.
Well, partly it's taken to these very strange images that are behind your head right now. These are pictures of equations. I've been, for the last 15 years, trying to answer the kinds of questions that my colleagues here have been raising. And what I've come to understand is that there are these incredible pictures that contain all the information of a set of equations that are related to string theory. And it's even more bizarre than that, because when you then try to understand these pictures, you find out that buried in them are computer codes, just like the type that you find in a browser when you go surf the web.
You're saying your attempt to understand the fundamental operations of nature leads you to a set of equations that are indistinguishable from the equations that drive search engines and browsers on our computers.
That is correct. So,
wait, I have to just be silent for a minute here. So you're saying as you dig deeper, you find computer code writ in the fabric of the cosmos.
Into the equations that we want to use to describe the cosmos, yes.
Computer code.
Computer code, strings of bits of ones and zeros.
It's not just sort of resembles computer code, you're saying it is computer code.
It's not even just is computer code, it's a special kind of computer code that was invented by a scientist named Claude Shannon in the 1940s. That's what we find very, very deeply inside the equations that occur in string theory and in general in systems that we can say are supersymmetric. Some of those codes are showing on the screen behind you right now. They don't look like codes, but these pictures, which we call adinkras, are graphical representations of sets of equations that are based on codes. That in the description of our universe, that is a supersymmetrical universe, which we were going to test in the LHC. If you believe that description, I can show you the presence of these codes.
So I can't go through the whole, the extra minutes there because we've got a little bit short on time, but it's very important for you to understand that this is this is from a very credible source. This guy leads the world in supersymmetry and supergravity, and what he's telling you is that the code that literally makes up what we consider to be our ether or our internal space here that we're dealing with in this universe, in the third dimension, can be broken down into computer codes, which means that it's very highly likely that we're living in a reality that it is a simulation. So it is a creation. The question is who created it. Okay?
The type that
You're saying your attempt to understand the fundamental operations of nature leads you to a set of equations that are indistinguishable from the equations that drive search engines and browsers on our
find in a browser when you go surf the web.
computers.
That is correct. So
wait. So you're saying as you dig deeper, you find computer code writ in the fabric of the cosmos.
into the equations that we want to use to describe the cosmos, yes.
Computer code.
Computer code, strings of bits of ones and zeros.
It's not just sort of resembles computer code, you're saying it is computer code.
It's not even just is computer code, it's a special kind of computer code that was invented by a scientist named Claude Shannon in the 1940s. That's what we find very, very deeply inside the equations that occur in string theory and in general in systems that we say are supersymmetric. Some of those codes are showing on the screen behind you right now. They don't look like codes, but these pictures, which we call adinkras, are graphical representations of sets of equations that are based on codes. That in the description of our universe, that is a supersymmetrical universe, which we were going to test in the LHC. If you believe that description, I can show you the presence of these codes. That's my statement.
Do you have any predictions in your ideas or any ways to test any of your ideas any more than, say, the guy over on the screen?
The work that I'm doing is, in fact, so theoretical that we don't understand yet whether it is even possible to complete the program. We have found these strange graphs. We know that they are equivalent to equations, and we have found in these equations computer codes. And so that's where we are right now. So I cannot give you a prediction. This work is less than 2 years old.
But it's not that you recognize that you will need a prediction in order to.
Someone recently asked me, said, well, you don't care about experiments, do you? And I said, no, that's exactly wrong, because you see, I have spent my career as a researcher worrying about supersymmetry. I would want to see an experiment before I shuffle off this mortal coil so that I know that I did not waste my entire professional life.
This is towards Dr. Gates. I'm curious about your theory. You say there's computer code in these equations. Now, computer code is generally just instructions for a processor. And I'm curious as to what the instructions you're finding are. And if you're not sure what's to say that it's actually computer code, I mean, theoretically, the number pi has all the data that's ever existed.
Well, we say that they're computer codes.
I mean the digits in pi.
Yes.
Yes.
Okay. We say they're computer codes, first of all, because the structure of the equation is such that they dictate that there are certain things that are actually strings of ones and zeros. That's just digital data. But it's not just random ones and zeros. As I mentioned earlier, let me talk about something that you probably do every day, but I don't know if you're a computer scientist or not. Most of us sit at our...
Sounds that kind of fluency, I said.
Okay, well, most of us sit at our computer screens and we type on the keyboards, and we then send these, if we're using a browser, we're sending strings of ones and zeros elsewhere. But on the other hand, in the transmission process, there's always some fluctuation. So 0 that you type here because of static in line might be read as a 1 at the other end and vice versa. And so in fact, when you sit and type on the keyboard, your computer's doing something behind your back. Namely, it throws in a bunch of extra ones and zeros, and these things are called error correcting codes, so that the computer at the other end can look at the whole collection of what you typed plus what was sent and figure out if there were bits that were being flipped back and forth. And that's how you get accurate transmission of digital data. Among the codes that are used for this purpose are a special class of codes that are called block linear self-dual error correcting codes. They were first, in fact, the Shannon extended checksum code is an example of one of these things. These are the codes that we find buried in the equations. Not just any code, but these self-dual error correcting block codes. It's quite remarkable for anyone that I've talked to. We have no idea what these things are doing there.
Any literature out?
I'm sorry?
Do you have any literature out that...
I can give you technical references that almost nobody in the world can understand.
But Jim, I thought you had a popular level article on this?
Thank you. Yes, actually, so this past June, the British journal Physics World asked me to write a popular level description of what we have found. So in the June edition of Physics World, and it's published in London, the cover story is called Symbols of Power. It's about these weird symbols that have been showing behind us. We call these things adinkras. And so for a popular level description, yes, we've written that. But other than this one popular level description, it's all technical gobbledygook. Wonderful. And that's a technical term, by the way.
Gobbledygook.
Thank you.
My interest in physics actually began as a child. It has three parts. The first part was about age 6 or 7. I had just learned how to read, and my dad brought home some books on space travel. I was born in 1950. Nobody had ever been in space. So when I was reading about space travel, this was like, the far edge of what one could think about. And I became very excited, and I thought about becoming an astronaut. About a year or so later, I was looking through some books my father had brought home. In those days, we didn't have the web, so when you had to do homework, you had to use these big things called Encyclopedia Britannica or whatever other encyclopedia your parents were kind enough to buy for you. So I was paging through this one volume, and I saw something odd. It had an equal sign in the middle, it had a bunch of plus signs, but the rest of it was literally Greek, and I couldn't understand what it was. And even as an 8 or 9-year-old, I recognized it must be some kind of arithmetic, I thought, because I saw an equal sign. But I wondered, could I ever understand whatever this thing was? And then finally, when I was in my junior year of high school, I took a physics course. I had a fantastic physics teacher, a gentleman by the name of Mr. Freeman Coney. And one day in class, he showed me the closest thing to magic I have ever seen in my life. He did this experiment where you take a board and you tilt it, and you let a ball roll down the board. And then you take a stopwatch and time it. And it turns out that the distance the ball travels down the board is proportional to the square of the time on the stopwatch. And he wrote this equation, and it describes what's going on. I was thunderstruck because I had always thought of mathematics as being an element of imagination. It was just like making up stories about space flight or reading comic books about superheroes. It was a game of play for me, and it was always inside of my head. But to see mathematics suddenly leap outside of my head and be in the world around me, I was like, how can this possibly be? And so, like I said, for me, this is the closest thing to magic I've ever seen. And at that point, I knew it was physics that I wanted to do, not just science. So we live in a universe, apparently, where equations describe things that go on around us. And so there's one set of equations that describe things like electrons. There's an entirely different set of equations that describe particles of light. And so the idea of supersymmetry is that maybe you can switch the equations a little bit. And, you know, that's what theoretical physics is all about. We're always asking the what-if question. And so when we talk about supersymmetry, we're talking about a world where the equations that we see in the laboratory can be switched, and we might find some new particles or new effects out in nature. And that's what I decided as a young graduate student was the most interesting thing I could pursue as a theoretical physicist. Well, first of all, I don't actually recommend students go into a science career unless they think it's going to be fun. For me personally, I couldn't avoid being a scientist because it was just one of the most fun things I had ever discovered as a young person. So the first thing is I tell students, whatever you want to have in life, and I'm sure most people want to be successful at some level, the first secret to success is asking yourself, what is it that's closest to my heart? I know that might not seem like the right place to start, but if you start with that question, then you're likely to find something that you'll fall in love with. And if you fall in love with doing something, it means you'll do it automatically and you'll do it a lot. And if you do something a lot, you get really good at it. And that's actually how you get to be successful, by being really good at something. So it actually starts by asking, what's closest to my heart? We're now at a point where some really interesting things are going on. First of all, in Geneva, Switzerland, there is a scientific laboratory called CERN, C-E-R-N. And at this laboratory, they have the world's most powerful particle accelerator. In fact, it's sometimes called the Big Bang Machine. And if any of your viewers have seen something like Angels and Demons, the movie, that big scientific installation in the movie is CERN. And so what's going to happen at this location are a set of experiments where physicists are going to actually see if these mathematical switchings that we talked about earlier, whether you can detect that in the laboratory. If that happens, then we will know that our equations are not just mathematics, but they're also a description about our universe. The other thing that's going on in my career is a little bit weird, and I'm almost a little bit loath to talk about it. I don't know if you or your viewers, and I'm sure some of them have gone to see the movie The Matrix. But in The Matrix, there are people like us, and they live in a world that's kind of like our world. And the only thing about their world is it's not what it seems, because the totality of everything that people experience is generated by a computer, so it's a virtual reality. Well, some of my research can be interpreted to suggest that we live in such a world, and that's just kind of mind-blowing. So by studying the equations that, that I've been knocking around with forever, in the last 5 or so years, I've been able to show that hidden inside of these equations, there are computer codes. They're the kind of computer codes that make browsers work. And so if the equations that describe our reality have computer codes hidden in them, that's just kind of weird. And in fact, it's so weird that I like to tell people, let's go back to the Matrix movie. If there were physicists in the movie and they want to know they were inside the Matrix, how could they do that? Well, one way might be to try to detect computer codes in the equations that describe their world. But that's what I've just proposed.